Okay, in this video, we're going to talk about the planetary model of the atom and kind of get a couple more steps into this idea of our atomic structure. So, planetary model of the atom is probably the model that you have most learned about in middle school and previous science classes. The model was developed by a guy named Niels Bohr in the early 1900s. He actually worked under Thomson and Rutherford as a graduate student at one point in his career. Of course, the planetary model, the basic idea behind that, electrons follow orbits around the nucleus like planets around the sun. So we're seeing electrons actually as an orbit, a nice repeating pattern over and over and over again around the nucleus. And we think the electron basically rides on this kind of pattern, throughout time. Okay, like I said before, probably what you've been taught before. So what we want to do is take a look at this model and bring it from what maybe you talked about in previous science classes to more what we really believe this model shows us in our world today. So to do that, we want to talk about, first of all, middle school. In the middle school model, we use the word shells. Okay, so there's the different shells the electrons kind of sat on: the first shell, second shell, third shell, fourth shell, and that kind of stuff. And you had 2 electrons in the first shell, and then you had 8 electrons in the next shell, and so forth and so on. Okay, not a bad way to approach it, but please kind of remove the word shells from your vocabulary, because there really isn't any shells out there. It's not like a Russian dolls that stack on top of each other. So no shells. A better way to explain this is that electrons work on set energy levels. Okay, so the shells, we really should think about being a set amount of energy, or a certain quanta of energy to them. Okay. Now, electrons always fill from the lowest energy level to the highest energy level, and we see that the first electron should fill in the first energy level, second, third, fourth energy levels, and so forth. Okay, we say that electrons only exist at certain amounts of energy. Okay, so in the planetary model, this is not something exclusive to the quantum model. The planetary model does have this idea of quantum of energy, or a very discrete, specific amount of energy to them. Very much like orbits around planets, that's thus the term the planetary model, the electrons could be at this amount of energy here, or they could be at this amount of energy here, or this amount of energy, or this amount of energy. But between the two energy levels, the space between them is completely void, which means the electrons are not allowed to be in those regions. Okay, they cannot have that much energy. Okay, having discrete amounts or very set amounts of energy are called quantum. Okay, we have a quantum of energy, or a packet of energy, basically, for those atoms. Okay, that's kind of a key part of the planetary model, because with these quanta of energy, that gives us reasons why there's space between them, and why each electron has a certain different kind of orbit to it, because it has a different amount of energy, so it would have a different orbit. Okay, now we know this model is not 100% true, because if you work out the physics, electrons cannot orbit along nice circular paths. If they did, comparing their speed to their mass into how an orbit works, like a planetary orbit actually works, the electron would actually collapse into the nucleus. So we know this is not right, but it's a very good visual model. It's actually one that I'll use a lot as we go throughout the school year. Now, that is the planetary model. We found out, though, that the planetary model really wasn't good enough. So there's some things that weren't lining up, some things that weren't working. So as a result, the planetary model is now our most recent obsolete model, and we now work under what we call the quantum model. Okay, in the next video segment, we'll talk about how that quantum model begins and how that works. Thank you.